Alright, so the first three problems from today's biweekly contest 140. The first problem, minimum element after replacement with digit sum. So we are given nums and we want to, uh, get the minimum element, which is nothing but, the sum of the digits, right? So this is 1, this is 3, this is 4, and this is 5. So the minimum is 1, that is 0, 0 plus 1. So we can just iterate through the numbers array, take the minimum, the answer as maximum initially, just iterate through nums, uh, get a sum, uh, while n sum plus equal to n mod 10, n by equal to 10, sum answer is equal to minimum of answer sum, return answer, space and time, space will be O of 1, time will be O of n, right? Time will be, see, iterating through the numbers array, and let me see the constraints, just 100, so it will be O of n only. Alright, the second problem, maximize total height of unique towers. We are given a maximum height array, and this array suggests towers which has a particular value which signifies its height, and we are asked to assign heights to each tower such that it is not exceeding this value as given here, and no two towers must have same height, right? No two towers must have same height. Then there might be scenarios where we are not able to assign, like here, because if we assign 2 as 2, okay, and then we assign height 1 for this particular tower, then we can't assign anything because the height should be a positive value. Otherwise, we should return -1 if it is not possible to assign. Alright, so right away, if we try to solve this mentally, we'll start from the highest and assign that value itself. Okay, so we are going to sort this in a descending order, iterate, start assigning values. So this will be the sorted order. The sorted order will be 4, 3, 3, 2, descending order. We start here, we assign 4 itself, we see 3, we have not assigned 3, so we assign 3. So right now my current height that I have assigned is 3, right? So we'll keep track of this. The next time we see 3, we see that we can't assign current height, then we make it 2. So we reduce it by 1 because we want the maximum total that is possible that we need to return, right? So we subtract it by 1, that's the highest that we can have, and we follow the rule that we are not repeating the height. That's why we subtract it by 1. We see 2, we can't really assign 2 because, sorry, my current height will be 2 now. We see 2, we can't really assign 2, so we make it 1, assign it here, we'll keep track of the sum as we go, that will be 10 here, we return that. Alright, so let's code it up. Sort maximum height, let me copy this, dot begin, comma, dot end. Here I will sort it descending order, so greater of end, I will have an answer to keep track of the sum of the towers, the sum of the heights that I'm assigning. I will have the current height, which will be int max for int I, or let me go this way, maximum height. Alright. So current height is what in this loop? It is nothing but the last height that I have assigned. That's the current height, right? So if current height is less than equal to n, which means I can assign, since the current height is the last assigned value for the last hour that I've seen, I want to assign so that it does not, collide with the last height, one less than the last height. So current height minus equal to 1. That's what I'm going to assign. Else, current height is greater than n, which means I should bring down current height to that particular height. So current height is equal to n, right? So at this point, I should add it, isn't it? But we are missing something. We are missing the fact that current height might get 0 because we are subtracting. So it might get 0, so that in that case we have to check if it is equal to 0, then return -1 here itself, else return here sum. Let's make sure that it doesn't overflow. And time complexity will be the sorting complexity, that's O of n log n. Let's not forget that we're using answer instead of sum. And space complexity will be O of n, O of 1, since we are not using any extra space. The third problem is essentially a DP problem, because it says that we are given two words, alright, and we are asked to return an array of indexes, alright, which is nothing but the smallest lexicographically smallest valid sequence of indexes, such that if we jump on those indexes, this will form ABC. But there is a catch, that we have a power to control at most, or convert or change at most one character which is not matching, right? So that it matches. So essentially, if this is the example, this is the word, this is the second word, we are given VBCCA, we want to form ABC, we can change V, use that power of changing at most one character to A, and then we can use BC. So 0, 1, 2 will be the lexicographically smallest valid sequence of indexes. Similarly here, BACDC, if we start from B, we are essentially changing B to A, then we want BC again, we don't have that. So we start here, we see A matches, we want to form BC, we change C to B, use the power, and go to the last character and form 1 to 4. That's the lexicographically smallest that we could have. Alright. Here are a few things to know, that at most one character is possible to change. We can't change more than that. Uh, I'm trying to find the word at most. Yeah, at most one character in X to make it identical to Y. Right. So there might be scenarios where it might not be possible. In that case, we should return empty, because there might be scenarios where it's not even possible to form, the character that we want, right? So that's the problem. Let's take an example. This is suppose word uh, 1, right? And this is suppose word 2. All right, and it's given we want to form the lexicographically uh, smallest array, right? So I've written this in caps because it's important. So if we see, if we start from the rightmost, uh, you know, index for word 1, and we see that we can form, and we see that we match, all right? So suppose we come here, so one character matches, and the jth index is here. This character matches, and suppose my DP array, which suggests that any particular in at any particular index, how many characters can I form? So this is that size of the DP at any particular index. From here, how many characters can I form, which is a suffix of p, right? Or suffix of word 2. So this is nothing but initially uh, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. All right. This is the initial DP, and just to uh, handle the base case, this is our initial DP. We are here. My I is here. I see that T matches. Okay, so I will say that one character can be formed. So I'll make this 1. Alright. Now I see D and B doesn't match. So I will say that from here also only one character matches. Alright. Now I am here. I am here. It doesn't match. So I'll do the same thing. So I'll do it together. So this will also not match. Till this point, these won't match, right? So this will be 1, this will be 1, and I will be here. I see that D matches. So I'll make this 2 characters. Now 2 character matches. Right? And this will also move. This will also move. I see that B, C doesn't match. It doesn't match. It doesn't match. It doesn't match. So this will also be 2. This will also be 2. This will also be 2. And this will also be 2. Okay. Now we want the lexicographically smallest, right? What do you mean by lexicographically smallest? If we think of bits, right, this becomes very significant, right? Because the most significant bit will be the one that we have to operate on, and if we can operate that and form the remaining, you know, it doesn't matter how, if we can form or not, if we know here itself, then I can say that I have my answer from here itself, right? So if I don't have the answer, I can just break out from here and return my empty array, right? So we are going to use this array and we're going to start here. And we have a power, right? So I'm trying to use that power as early as possible, or let me power. So right now I have that power. I have not used it. I will see that this and this doesn't match. Suppose it would have matched, then I could not use the power. It's not good. I don't want to waste my power, so I'm not going to use it. But since this was not matching, so I have to use my power. I will use my power. I'll make this 0. So now I don't have power. I will move forward. By the way, before moving forward, I should check that can I even form the characters now? For that, I'm going to use this. Since from here, that is from here index, from this index, I have two characters, right? And my J is here, my I is here, right? I'm starting from the beginning now. My J is here, my I is here. I'm going to use the power so I don't have to worry about the first index. I'm going to make it match forcefully. The remaining characters are BD, that is 2 in number, and I have 2 in number here as well. So I can form if I use the power here. So now I don't even have to worry about using the power. Since I've used it, I will move forward. I will keep on checking, and this also moves forward because I've used the power. I will keep on checking if it matches or not. This matches. I will add the index in my answer. Uh, this was added, so 0 is already added. 0, 1, 2, 3. Now 3 is added. I will move forward. This will also move forward. Just matches. So as soon as I match, I will answer. I'll put it in my answer. 0, 3, 4, 5, 6, 7. 0, 3, 7 will be my answer. Now this goes out of form. I don't have to check anything, and that's it. That's how we're going to solve this problem. Alright, so let's start coding it up. I will have the lengths inside m and n. So word 1.length. Here I'll form the DP. So I'll have a DP vector of n of size m plus 1. Why plus 1? I'll just figure it out in a minute. Vector of m plus 1 size or values will be initially 0. I will iterate from the end. So m minus 1, I greater than equal to 0, I minus minus. I will have one extra because at this point I will check how many characters beyond this can I form from here. Well, I can form 0 characters plus the one that I matched, right? So essentially I'm taking the state from the next index. So dp of I is equal to dp of I plus 1. For this I plus 1 I have this extra m plus 1, and if the match happens, word 2 of I, or sorry, j is equal to, by the way I also have a j, I have not defined it. Let me define it here. J is equal to n minus 1. Alright. So word 2 of j, word 1 of I, is it as a match, then I will do a j minus minus. But before that I'll also do, since this is a match, then I will increase the character count that I've matched in my DP. So DP of I plus plus let's not forget that P, J and I, that is word 1 and word 2, can be of different lengths. So at this point, it might go out of bounds. So I will check that if J is greater than equal to 0, that is the case, only then continue. I'm not keeping this J greater than equal to 0 here because what if they are of different lengths, then this won't happen, right? I want this to happen because if I can form two characters from here, they can obviously at least form two characters from here as well because I can from here, that's why. So I need this, that's why I'm not keeping this here in the loop. Now that I have the DP formed, I will start iterating from the beginning now. So I'll make int j equal to 0 and int I is equal to 0, I less than m I plus plus, and I don't want to continue. Now if I have exhausted word to 2, so j should be less than n. I will check if uh, the word of I, word 1 of I is not matching with word 2 of j. So I'm going to use the power here, right? So I'll have a power. To determine if I have a power or not, I will use value 1 to signify that I have power. Have power. And if a power is 0, then it will be that I have used the power. So at this point, if the power is uh, if it is 0 or if it is 1, only then I'm going to use it. And the next thing I'm going to see is that here, if this does not match and my power is 1, then I'm going to use this power. But before using it, I'll also make sure that the remaining characters and the character match from here, from the next index, if it is matching or not. So 2 is greater than equal to BD, that is 2, and that can be determined using n minus j minus 1, right? That's going to give me the count of the remaining characters. If that is less than the one that I see here, then I can go ahead and use the power. So dp of I plus 1, if it is greater than equal to n minus j minus 1, right? In that case, I am going to match it forcefully, make the power used. So I will use the power and make it 0, and this should be equal to by the way. And I'm going to insert the answer in my index in my answer. So I will have a vector of int answer dot push at I. Let else. So else, if it is matching, if word of 1 I is matching word 2 of j, in that case I will do the same thing here as well, right? If it is matching, then I will do the same thing here, and by the end my answer should have this exact number of indexes, right? So if it is not, then I'm going to return invalid case, so empty array. So size should be equal to n. If it is not, then return empty array, otherwise return answer. Let's see if this works. Let me not redefine J. Exhaustive. This works. The time complexity will be O of n, and the space complexity will be O of n, and that's the third problem. Thanks, guys.